we are now looking at target 6B. And it says determine that two figures are similar using angle, angle, side, 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 and side angle, side similarity by verifying that angle measure is preserved and corresponding sides are proportional and used to make conclusions. Very long. So what we're going to do first, 6B.1, is I can identify congruent angles and proportional sides by using the properties of similar figures. So we first want to figure out what a similar figure is. So we just talked about dilations, where dilations are, it changes the size of the shape, but not its actual shape. And what we find out is that dilations create these things called similar figures, okay? So similar figures are two or more figures that have congruent angles and proportional sides. Okay. They have congruent angles but proportional sides. So what do these things mean? Well, proportional sides, proportional means, right, the scale factor of all sides, the scale factors of all sides are equal. Okay? So when I do new over old for every single side, right, then all of those fractions or numbers should be equal. Okay, so proportional is really the fractions are equal. And then we have our congruent angles. Congruent is just the same as equal. Okay, so if one angle is 34 degrees, the other angle is 34 degrees. They are equal. Okay, and this gives us two things that are the same shape, right, but different sizes. So, right, the congruent angles, the angles are all equal, so our shape is not getting like wider or narrower or anything like that. But then the sides are just proportional, right? So that could be their different sizes, right, as long as the fraction stays the same. All right. So this picture shows that, right? If you look here, my corresponding angles, my angles that go together, A and W are like in the same spot, right? That makes them corresponding. They are congruent. This is our symbol for congruent. Let me add that to this. This is our congruent symbol. Okay. B is congruent to X, C is congruent to Y, and D is congruent to Z. So this shape has four angles, and all four angles are congruent to all four angles over here. Okay. Same with our sides. It has 1, 2, 3, 4 sides, and I can do AB over WX, BC over XY, CD over YZ, and DA over ZW. Okay? So again, I can do the same thing where I'm writing my fractions. So let's look at an example where we do this kind of thing ourselves. Given, for example 3, we're given that this triangle M to N to P, is similar. This little squiggle means similar. Okay, so we'll be using that a lot, so it's good to know that the little, just a squiggle, no equal sign, means similar. But what are our congruent angles? So I just have to choose an angle in my first shape and then figure out what angle it's congruent to in my second shape. So I'm going to start with M. Okay. So again, how do we name it? We can just name it angle M. Nice and easy. And which angle does it seem to be the same as, right? Well, if I look, it looks like this shape has been rotated, and that's okay. But this angle is corresponding with this angle S over here. You gotta think about how I can match the shapes up. So angle M is congruent to angle S. The other thing you can look at, which is very helpful, is to use the name of the triangle. If I look, M is in the first spot and S is in the first spot. Okay. So those are going to be my corresponding ones. Same thing, right? If I move on to this P, I'm going to put 2 markings onto this P. Again, if I flip this whole triangle around, we should maybe see that it goes with, let me make these 2 nice markings, T. The other thing I can do is, hey, look, I have P here. It's in the last spot. T is in the last spot. So angle P is congruent to angle T. Again, I use 2 lines here because while these are congruent to each other, it has nothing to do with M. So you change the number of little line marks you make, right, to differentiate between your different angles. And then we have our last angle, angle N. 1, 2, 3 now. And 1, 2, 3. Or again, N is in the middle and R is in the middle. All right, what are the proportional sides? Same idea, but now I just have to choose a side. And instead of them being equal, right, they're proportional. So we have to set up a fraction. Right? Remember, proportions, ratios, those are all fractions. Okay, so I'm just going to choose a side. I'm going to go from M to P. Over, I started at the red angle and went to the blue angle. So I'm going to start at the red angle and go to the blue angle, S to T. Okay, so if you already have your angles kind of labeled, it makes it a little easier. Then I have, right, I need to do another side, so I'm going to do this side, P to N. Right, that's my blue angle to my green angle. Same thing here, blue angle to green angle is T to R. And then green angle to red angle is N to M. And green angle to red angle is R to S. Okay. So proportional, again, it's fractions, but it's equal fractions. So I have my 3 fractions, and I'm going to set them equal to each other. So fractions are equal. And that's it for this one. We are done here. Okay, go ahead and look at your next page. One last example. Determine whether the 2 triangles are similar. Well, again, with similarity, I need to show that my angles are congruent and my fractions are equal. So I have angle B here. It is 27 degrees. And so then I want to look, do I have something that is equal to? Yes. Angle F is also 27 degrees. So angle B is congruent to angle F. Angle A is 117 degrees. Angle H is 117 degrees. They are the same. And then angle C is 36 degrees, and angle J is 36 degrees. So angle C is congruent to angle J. Okay, my three angles check out. Again, it's a triangle, so you're doing three things, right? Same thing with my sides. A triangle also has three sides. So I'm going to do the same thing, and this is just like finding your scale factor. I have B to A and F to H. To get us back into the habit of when we were doing scale factor, I'm going to do new over old. So let's call this my old and this my new. For these ones, it does not really matter. Only that whichever one is your new is always your new. So I usually end up with these ones reading left to right. So old and then new. Okay? So my red sides that I just labeled. All right, I'm going to do equals new over old, which is 4 over 8, which equals 1/2. Then I'm going to do my blue to my green side. And my blue to my green side. Again, K equals new over old. My new is 3, and my old is 6, which reduces to 1/2. And then my green to my red side, and my green to my red side. Again, K equals new over old, which is 6 over 12. Which equals 1/2. All right, look, I have 1, 2, 3 sides and 1, 2, 3 angles and 1, 2, 3 sides. So yes. And now I need to name my triangles. Triangle, if you have set up your angles correctly, it gives you a nice, easy thing to read. I'm going to call it triangle BAC. Is similar to triangle FHJ. Okay, that's it for this. This problem was a little longer. And so it's good to know what we mean. We're going to do this activity. And then our next 4 activities, are teaching you shortcuts so you don't have to do all of this work. Okay? Otherwise, have a good, go ahead, work on your activity, and then watch the next video.